Hello everyone. I'm Wing-Hong Shan, a PhD candidate at Peking University. The paper I will be presenting today is titled, Diffusion-Based 3D Human Pose Estimation with Multi-Hypothesis Aggregation. Given a 2D pose sequence, 3D human pose estimation aims to learn a model that can localize the positions of human joints in 3D space. Existing work can be divided into two categories. Deterministic methods will predict a single 3D pose given a 2D observation. These methods are practical in real-world applications. Probabilistic methods use generative methods to predict multiple possible pose hypotheses. These methods preserve the uncertainty and ambiguity in 2D to 3D lifting process. Our goal is to combine these two methods. Besides, there are a number of problems with existing probabilistic methods. For example, they rely on special network designs or cannot specify the number of hypotheses. Diffusion models have strong generative capabilities and show remarkable progress in numerous areas, including image generation, cross-modal generation, etc. Therefore, we apply diffusion models to probabilistic 3D human pose estimation, which is then combined with a deterministic method. And then our framework was born. During training, we add Gaussian noise to the ground truth 3D poses, resulting in contaminated poses. Then, these poses are sent to the denoiser to predict the 3D results. During inference, we sample from Gaussian distribution and get multiple pure noise 3D poses, which are passed to the denoiser. The generated possible 3D pose hypotheses are combined into a single prediction using the proposed multi-hypothesis aggregation method. Let's dive into the process of hypothesis generation. During training, we add T-step Gaussian noise to the ground truth and use the time step and 2D poses as guidance for denoising. During inference, we sample H times from Gaussian distribution and use iterative denoising to refine the results. Compared with existing methods, our method supports reusing existing 3D human pose estimators as the backbone and supports customizing the number of hypotheses and iterations. Next, we pay attention to the process of hypothesis aggregation. Existing works select the pose which is closest to the ground truth. When the ground truth is not available in real-world applications, they simply average all the hypotheses. These methods ignore the differences between joints and fail to establish the correspondence between 3D outputs and 2D inputs. To alleviate the first problem, we propose a joint-by-joint aggregation method, which exploits the merits of each pose hypothesis. To alleviate the second problem, the reprojection method is used. We combine these two aspects to get the final method. 3D pose hypotheses are reprojected to the 2D camera plane and compared with the input 2D key points. For each joint, we select the best hypothesis that has the minimum distance to the 2D input. Then, all the selected joints are combined into the final 3D prediction. We choose the state-of-the-art deterministic method and combine it with the diffusion model. With diffusion models, our method has the ability to generate multiple hypotheses. Performance gain is also observed when the number of hypotheses is 1. Besides, experiments show that the upper bound of performance for aggregation at the joint level is significantly higher than that at the pose level. When the ground truth is not available, the proposed joint-wise reprojection-based multi-hypothesis aggregation method is more effective than existing pose-level aggregation methods. For the cases of 2D misdetection, self-occlusion, and rare poses, our method generates highly uncertain predictions to represent the possible locations of 3D poses. When the pose is relatively simple, our approach tends to generate deterministic results. More qualitative results under the cases of low illumination, fast motion, animation, monkey poses show the robustness and generalization of the proposed method. That's all. Thanks for watching.